Hey all, Mr. T-Bones here. Going to jump into the practice set for lesson 97. Write a recursive formula for the following sequence. So remember, recursive formula is a formula that you need to know the next term for. Okay. When we write a recursive formula, we also indicate the first term of the sequence. In this case, the first term is 3. Okay. And then we go ahead and we use a minus 1 to figure out the term right before. Okay. So here we have first term is 1. So n equals 1 for our first term. A1. A1 equals 1. Okay. And then for A of n, it's going to equal, well, we have to figure out a little bit here. Is it adding by 3 each time? Doesn't quite look like it, okay? Because here, it goes up by 3. Over here, though, it goes up, it doubles. It's, we get, here, it goes up by 12, and then over here, it goes up by a lot more, okay? Now, if you are pretty familiar with this, 4 times, all of these, so 64 is really just 8 times 8, right? 16 is 4 times 4, okay? Or you could look at this as 2 times 2 equals 4. 2 times 2 times 2 equals 8. Oh, that's not what's going on, though. 16 times 4 is 64. So it's multiplying by 4 each time. Okay. So here we're going to have, let's see, my first term is 1. So we're going to use a n minus 1 times by 4. Okay. So whatever the previous term was, multiply it by 4 to get your current term. Okay, so if my current term is 1, then 1 times 4 is going to get me my my next term, 4. Okay, for my next, it's 4 times 4. For 16 times 4, it gives me 64. So my next term on the sequence is going to be 64 times 4 to get me my 5th term. Okay, so that's A. B here. The terms of the following sequence are generated with the formula an equals 5n minus 2. Write a recursive formula for this sequence. So A1 equals 3, and then we get why is that different than so so the recursive formula is, if you start with 3, it's going up by 5 minus 2, 5n minus 2. So we do essentially n times 5 minus 2, so 2 times 3. So if we're going to do a recursive formula, the first term is 3. And then for a of 4, oh, it's going up by 8 to 13, 3 to 5. Oh, it's just going up by 5 each time, right? So a of n minus 1, so the term before, plus 5. Okay? A of n equals... Yeah, I hate these things. They're so stupid. Sorry. So the recursive formula, which is the one that asks you to solve it by knowing what came right before it, is saying the number before it, a n minus 1, plus 5 gives you the number you're looking for. So if I have 1, 2, 3, 4, so 18 plus 5 equals my sixth number of 23, right? So that is a of 6. I can solve it again by doing 5 times 6 minus 2. 5 times 6. Oh, I didn't want my fifth. I want my fifth number. Sorry, that's why that one didn't work. So 5 times 5 is 25, minus 2 equals 23, which is the same as this. Sorry. All right. Mr. Tivido hates these. They just are so... If you already have the sequence, why do you need the recursive formula? The recursive formula, I honestly don't know why it's a thing. I'm sure it's helpful somewhere along the way, but it never made sense to me. C, one of the terms in the sequence is 729. Write a recursive formula for the sequence and find the term that follows 729. Okay, so first I guess we have to figure out what the just general sequence, what is happening each time. So 1 goes to 3, 3 goes to 9, 9 goes to 27. Okay, so it is the first term, a of 1 equals 1. Okay, now what's happening is it is going to be the n times 3. 3 times 3, 4 times 3. That's not 4 times 3. That is the previous number times 3. So the recursive, so what's happening here is, so it's being exponent, not exponent by 3. Squared? No. In any case, what we'll do is we'll do a n minus 1, whatever the previous term was, so 9 times 3. So whatever the previous term was, multiply that by 3, and that's going to give us our a of n. Okay? So one of the terms of the sequence is 729. I guess just 27 times 3. I'm just going to do it this way. I'm sure there might be an easier way. So 27 times 3 is 81. So 81 is my fifth term. Times 3. 243 is my sixth term. And then I'm guessing that that's the answer. So my seventh term is 729. Okay. So find the sequence below. So my fifth term, my sixth term, my seventh term. Sixth term is 243, which is what it wants. I hate this so much. D, which formula below generates the terms in the following sequence? So first, let's figure out what the heck's happening. So my first sequence number is 2, so both of those could be right if we're doing recursive. Then we have, it goes up by 1, it goes up by 2, it goes up by 4, it goes up by 9, goes up by 6. So plus 1, plus 2, plus 4, plus 6. Is that plus 8? No. Oh, also this is plus 8, not. So is it going up by 16? It's going up by 16. Okay. So what's happening is the n, the number, is being multiplied by 2. So start with 2. 2 times okay, so it looks like this one is right, because if you do 2 times your second number, that's 4, minus 1 equals 3. If you do 2 times your third number, that gets you 6 minus 1 equals 5. 2 times your fourth number gets you 8. Then why is it not 7? Should be 7 if it's that. Oh, because it's going to be, it's not times 4, it's times the number that preceded it. So it's 2 times 5 minus 1. So over here, now it's 2 times 9 minus 1. 18 minus 1 equals 17. Okay. Yeah. All right, well, I guess that's it. But it's A is the answer. I hate these. Because I hate these so much, I'm going to give you a lighter load. I'll just ask you to do 14 through 25. Also 9 problems. Have a good one, my dude.